Hi, it's Jill, and today we're going to talk about the nervous impulse. Okay, this is a video of a nervous impulse, and this is the beginning stages of the nervous impulse. Here is a picture of my nervous impulse, and the process of what happens through the dendrites and through the nucleus and through the axon. And the action potential is actually a chemical signal that is being released upon in the synapse area. So what we're going to take a look at today is what is happening inside of a neuron. And over here in this picture, I want you to take a look at. This is a part of a cell membrane. And we're going to take a look at what is happening and the difference between the extracellular fluid and the intracellular fluid. So we already know that in the cell membrane, it's a semi-permeable structure that surrounds the cell contents, and it separates what's inside of the membrane to the outside of the membrane. We know for sure that inside of the membrane, we have a high concentration of potassium. We also have a high concentration of proteins. And proteins are always a negative charge. They're always negative inside of the cell. We also, on the outside of the cell membrane, we see that there are,
we are at resting potential.
The sodium. There's a high concentration of sodium. There's also a high concentration of calcium
inside of the extracellular fluid.
If we have a sodium channel and a potassium channel inside of the cell membrane of the neuron, these channels, as we can see, are closed right now. If they stay closed, the sodium and the potassium cannot move in or outside of the neuron. And the sodium will want to go out, and the sodium will want to go in, and the calcium will want to go out. But for these channels to open, there has to be some sort of impulse to open these channels for the sodium to go in and the calcium to go out of the extracellular fluid and the intracellular fluid. A stimulus must happen. And a stimulus such as anything like eating, flexing, any sort of movement that you have, these channels will open in those channels for that to happen. Okay, so we're going to use this example to explain of what happens inside of the cell membrane when we go along and have a stimulus that happens. So at resting potential, you see here that we will start at the negative 70 millivolts. And that's just if we're going along just fine, nothing's happening. And when there is a stimulus that will happen, we will see that the sodium gates will begin to open. And sodium will rush into the neuron. And if the membrane potential is at negative 70 and there's a positive charge of sodium that comes in, it will change the membrane potential and it will increase and become more positive. So it doesn't stay at the negative 70 when the impulse happens. This is called the threshold. Then the voltage gated sodium channels will open. So we see here that if we're staying at negative 70, whenever there's an impulse that happens, what happens is the sodium will go just shoot straight up with all of the positive ions. And all of these sodium channels will open and the membrane potential will change. And when it changes, it will come up to here and it is called threshold for the stimulus to go up. The potassium channels then open they begin to rush out. And then the potassium channels also open at the same time as the sodium channels open, but they are slower than the sodium is. At the threshold, the potassium will then open up. At the threshold, the sodium actually closes at that moment. And then the potassium opens up. And when the potassium opens up, then all of the potassium channels will rush out. And it will cause the membrane potential to go down. And it will return to its resting potential. And when it gets down to the resting potential, the gates will close. So the sodium and the potassium pump will be reestablished by the membrane potential back to its resting potential.